In this lesson, we'll be learning the basics of congruence and similarity. So congruent shapes are the same. They may be translated, reflected, or rotated, but they're exactly the same shape and size. Similar shapes have an identical shape, but may be of a different size. So congruent shapes may be translated, they may be rotated, reflected, but they must be the same size, so they cannot be enlarged or dilated. Similar shapes are the same shape, but may be of a different size. So all of the following shapes are similar. This one has been enlarged and reflected, dilated or made smaller, and then reflected, rotated, and then reflected. So all of those shapes are similar. In order to construct similar shapes, we perform the following. You'll need pen and paper and a ruler in order to complete this. So the diagram at right shows how to enlarge triangle ABC using a scale factor of 2. So we start with triangle ABC, A, B, C, and when we're finished we'll end up with a similar triangle which is twice as large, which will be A dash, B dash, C dash, where point B maps onto B dash, A maps onto A dash, and C maps onto C dash. So we start with triangle ABC, then we choose a center of enlargement, Q, outside of the shape, and the position of that is arbitrary. Then we make sure that the length of QB dash is twice the length of QB. So the scale factor is 2, therefore Q to B dash must be twice Q to B. Similarly, QA dash is twice Q to A, and the same for QC dash and QC. Now note, if the scale factor was 3, then Q to B dash would be 3 times QB. You repeat that process, as I've just said, for all vertices. In this case there are 3 vertices because it's a triangle, and you have then created an enlarged triangle with a scale factor of 2.